Hello Pre-Calc Excel students, and welcome to lesson 4.8. We're going to go through some more applications in this section, and we're going to talk about bearing angles. So we'll get to that. I wanted to start off with a question where you're asked to solve the right triangle. And just to refresh your memory, when you're solving a right triangle, that means to find all of the missing sides, all of the missing angles. Standard lettering must be used. So we use capital letters for the angles. C is always the right angle. And then opposite each angle is a lowercase letter to represent the side. So opposite angle A is side A, opposite B is side B. The hypotenuse is again C. Okay, so given this info, set up some trig functions and solve for all the other missing parts. Pause the video, come back, and we'll compare solutions. Okay, so hopefully you got these lengths, and of course angle B is 70, right? It's the complement of A. If you did not get these side lengths, ask about it in class and we'll go over that. Okay, so on to bearing angles. We have two different types of bearing angles. So the first type we're going to talk about is the type where we add direction to the angle measure. The angle measure will always be an acute angle. And by direction, I'm talking about north, south, east, and west. So there's lots of different sayings I've heard over the years to remember this order. If you go around in the clockwise order, some people will say never eat soggy waffles, never eat shredded wheat, which I happen to like shredded wheat, so I don't usually say that one. Never eat sour watermelon. There's lots of different things you could probably come up with. Maybe you can teach me a new one. So using these directions and measure, your bearing angle will always start with north or south. So we start in that direction and then we turn to either east or west. So this bearing angle here, angle number 1, this would be a northeast bearing, and I don't know, I'll estimate that to be about 30 degrees. So we would say north, 30 degrees, east. Bearing number 2. Now I'm starting from the south and rotating, so this one went this way, starting from the south and rotating to the east. So this will be a southeast bearing, and let's say that's about 60 degrees. So south, 60 degrees, east. This one looks like it's pretty much right down the middle. Okay, this would be a southwest bearing. So we're starting from the south, rotating to the west. So we would say south, 45 degrees west. You may also see this in a problem as just southwest. Okay, southwest, southeast, northwest, northeast. When you see that with no angle, it means directly southwest, which means right through the middle of the quadrant. So keep that in mind in case you see that something traveled southwest with no measure. If it says that something traveled in a direction north or south, east or west, it's directly in that direction. Okay. The fourth bearing. Now we're starting north, rotating to the west. So let's say that's about 20 degrees. So north, 20 degrees west is how we would write that angle. So notice none of these angles are made with the east-west line. All of them are made with the north-south line. So if I'm drawing a bearing angle that's south 70 degrees east, let's see, let me get a line here. Okay, so I'm starting south and I'm rotating 70 degrees to the east. So this angle here is my 70-degree bearing angle. Okay, here's the due south, due east, etc. So again, this is due south. Let me make my line a little thicker. Due south would mean straight down. Due east, over to the right. Okay, and so on. My straight down kind of got shifted there. There we go. Okay, draw a bearing angle that is north 70 degrees west. So I'm starting to the, starting to the north and rotating to the west 70 degrees. So this angle here would be my 70-degree bearing angle. Okay, now the second type of bearing angle is called aerial navigation. With aerial navigation, everything is going to be different from what we just talked about, and it's going to be different from our unit circle. So for aerial navigation, we start 0 degrees north, and we rotate in a clockwise direction. So east would be 90 degrees, south is 180, and to the west is 270. Full circle, of course, 360 degrees. So for aerial navigation, your angles will be somewhere between 0 and 360. And the way you can tell the difference is, again, that the other type of bearing always has direction associated with it. So if I say north 30 degrees east, you know that's this type of bearing. If I just say 30 degrees, it's the other type. And to be honest, they would be the same, right? Because I'm starting north and rotating to the east. Now, if I said north 20 degrees west, that's not the same as 20 degrees for the aerial navigation, because now I'm starting north and going to the westerly direction. So an angle of 310 degrees. So now I'm starting again 0 degrees north, and I rotate around. I'm going to pass 180, I'm going to pass 270 and go about 40 degrees more. So the important thing is knowing that this is 40 degrees, this is 50 degrees. You could be using one angle or the other. To sketch an angle in the direction of 65, again, start 0 degrees north and rotate 65 degrees. So this here angle is 65. 190. Again, I'm starting 0 degrees north and I'm rotating past 180 just a little bit. So I know this angle here is 10 degrees and this angle would be 80. Okay, so I'm going to help you get started on this problem and ask you to finish it up. We have a sailboat that leaves the pier and heads due west. So again, due west means directly to the west. After 15 minutes, it changes course to north 16 degrees west. So what I'm going to do here is draw in a little north, south, east, west line intersection. And I'm going to draw my bearing going off northwest 16 degrees. So again, I'm starting north and I'm rotating to the west 16 degrees. So this angle here that's made with the vertical is 16. Okay, so let's see about our lengths here. So we're going at 8 knots. After 15 minutes, that's a quarter of an hour. So a quarter of 8 knots, this is 2 knots. Now we're going 10 knots. And after 12 minutes, we're asked to find the distance and the bearing from the pier. So let's put a P here for the pier. So let's see, 12 minutes, that's a fifth of an hour. And a fifth of 10 is also 2. Okay, so look at what kind of triangle you have here. You make this look a little bit better because those lengths are the same. So we're asked the distance, and this is important that you read these questions carefully. We're asked for the bearing in the distance from the pier. Distance doesn't matter so much, but the bearing does. Right? If you did from the boat to the pier, you'd have the wrong direction. So what you're looking for is this angle here, right? However the bearing is given to you is how you want to give your answer back. So this is the type of bearing with direction. So your bearing angle here should be a value associated with direction. And then you're also finding this distance from the pier to the current location of the sailboat. So pause the video, see if you can find these two things, and then come back when you're done. Okay, let's see how you did. So there's the work. I drew in the altitude of this isosceles triangle. It gives me 2 congruent right triangles. It bisects this vertex angle. So we end up with a 53-degree angle here, which allows us to solve for the distance. If this angle is 53, this angle is its complement, and this angle is its complement, is the complement of 37. And that's my bearing angle. And this direction is northwest. Okay, let's try one more. So here we have a helicopter that leaves New York City and heads towards Princeton in a direction of 235 degrees. The distance between the two cities is approximately 51 miles. How far south and west is Princeton relative to New York City? Round to the nearest hundredth. So let's start with a north, south, east, west intersection. This will be at New York City. And then my bearing, this is the aerial navigation bearing. Notice no direction is associated with it. It's not an acute angle, right? So that's how you can tell the difference. I mean, the real giveaway is not having north, south, east, west associated with the angle. So I'm going to start north, and I'm going to rotate 235 degrees. Remember, south is 180. So there would be my 200 from here around. That's my 235 degree bearing angle. What I'm going to use, I'm finding how far south and west I'm going. Oops. Okay. So here's west. Here's south. If that's 235, then this angle is 55, right? Which leaves me with 35 for this angle. So go ahead and find those distances and find the bearing from Princeton back to New York City. Okay, so here's Princeton. And we want this angle here, you want to give it an aerial navigation, just like the other angle was given. So pause the video, try that, and then come back when you're done. Okay, let's see. So we have a 55 degree angle here, and that gives us our bearing. Right, that is the aerial navigation, because remember 0 degrees is north and we're only rotating that 55 degrees. And then I can use the sine and cosine functions to find those distances. So that's really it for this lesson. The only new thing is the bearing angles. You're going to see angles of elevation and depression again as well, but this was really the only new thing for the section. So I hope you enjoyed the lesson, and I'll see you in class. Have a good day.